We are continuing with Lecture 3 for Electrochemistry Part 1, the galvanic cell. Let us quickly cover what has been taught in Lecture 2. So what does a more positive E naught value means? It means that the forward reduction process is favored. So the species on the left-hand side of the reversible equation will be a stronger oxidizing agent. So what will a more negative E naught value stands? It means that the backward oxidation reaction will be favored. The species on the right hand side is a stronger reducing agent. Okay, and we need to know the mathematical relationship between the standard electrode cell potential and the change in Gibbs free energy. So when the standard electrode potential of a galvanic cell is bigger than 0, it means the change in Gibbs free energy is negative, because the relation says that change in G equals to minus NFE. This will mean that the reaction is spontaneous. And lastly, how do you calculate the uh, voltage of a galvanic cell? You take reduction minus oxidation. What we will be doing for the last lecture of the galvanic cell is we'll be practicing more examples to calculate the E naught cell. We will also learn about the limitations of the E naught cell. We will also learn how can we construct fuel cells and the calculation of the E naught cells related to fuel cells. We will now take a look at the question in checkpoint 5. So this question asks you, what will happen when aqueous H2O2 is added to Ki in an acidic medium? Okay, so before I start, we need to learn how to interpret the questions. So when they say H2O2 in water is added to Ki in an acidic medium, H2O2 Ki are the reactants. That means in the overall redox equation, you would expect to see maybe H2O2 with I minus or K plus or even H plus on the left hand side of the equation. Okay, so what are the species that we should be concerned with? Okay, and is the reaction spontaneous? This can be proven by calculating the E naught cell, whether it is bigger than 0. And after we have written the overall cell equation, what are the color changes that you may observe? Any gas evolve? These are the possible answers. So what should your thought process be? We need to know what are the things that we need to look out for. Basically, what are the species that might participate in the redox reaction? So there are a few choices: H2O2, K plus, I minus, and H plus. Okay, so what we need to do now is to look for the relevant reduction potential values from the data booklet. And there's another question that we should put at the back of our mind first is, do we need to consider water? Because water is also present because aqueous medium is used. So from the data booklet, you will need to hunt for the species that are of interest to you for this particular question. So the species may appear on the left hand side or the right hand side. So please be aware, if it appears on the left hand side, that means it's undergoing reduction. If it appears on the right hand side, it means it is undergoing oxidation. Okay, so we will continue. So we will continue to look for the relevant species in our data booklet. So what we can see here is for H2O2 is a bit more complicated because H2O2 can appear on the left hand side. That means it has a choice to undergo reduction, or H2O2 can appear on the right hand side where he has a choice to be oxidized. So let me write it down for you. So this one, you want to consider it as a reduction, and for H2O2 on the right hand side, you want to consider it to be oxidized. After picking out the relevant data from the data booklet, we will write it down, and the next thing to do is to identify the reduction and the oxidation half equations. So there are a few that we have to select. So the thing is that we have to choose the most favorable reduction, the most positive standard electrode potential values, and the most favorable oxidation, which is the least positive standard electrode potential values. So after selecting them, we can write them down in the correct direction. So let me write it down on the slide. The reaction number 1 is actually a reduction. Reaction number 2 is an oxidation. So if you were to combine the two half equations, which is quite easy to combine because the number of electrons is the same, so you do a cancellation, you can easily write down the overall equation for the redox reaction, and then we can calculate the E naught cell. The voltage is plus 1.23 volt, bigger than 0, which means that the reaction is spontaneous. Okay, and what can we observe? So if you look at your overall equation that you have written down, you see I2 being produced. I2 in water is brown. So do we need to consider water for the question in checkpoint 5? First, we take a look at the data that can be found in the data booklet. Water can be reduced as well as oxidized. So they are given in red on this slide. Okay, but even if you include water, right, they still do not need to be taken into consideration because I would have chosen plus 1.7 volt for reduction and plus 0.54 volt for the oxidation. So to conclude, we do not need to consider water. Okay, anyway, in an ecosystem, if water is the reactant, then there is actually no need to tell you that there is H2O2 and Ki that is present in acidic medium. So generally, there is no need to consider water when you are trying to pick out the correct equations from your data booklet when you are doing the calculations for galvanic cell. So let us now look at uh, attempting the questions in checkpoint 6. So SnCl2 with Br2 in water, K2Cr2O7 with HCl in water and acidic medium. So what you have to do next is to look at the species and hunt for the relevant standard reduction values from your data booklet. So for checkpoint 6A, we should list down the species that are present, Sn2 plus, Cl minus, and Br2. So we look for this species both on the left hand side and the right hand side. And for the reduction, you have minus 0.14 volt and plus 1.07 volt. So it should be quite obvious which one you choose for the reduction, the one that is more positive. For the oxidation, you have plus 0.15 volt and plus 1.36 volt. So again, we should choose the less positive one for the oxidation. So let's continue. The more favorable one for reduction, which means plus 1.07 volt, more positive value. For the oxidation one, we choose the less positive or more negative E value. So once we have identified the reduction and oxidation half equations, we will continue in the next slide. So after successfully choosing the reduction half equation and oxidation half equation, we can try to combine them. So let me write it down on the slide. So this is the reduction and this is the oxidation, and very happily we can cancel out the electrons transferred, and you can get the overall balance equation for the redox process, and we can calculate the E naught cell. The E naught cell show that the E naught cell is a positive value, which means the reaction is spontaneous. Okay, we will quickly continue with the question in checkpoint 6b. Again, we list down all the species that you need to consider: K plus, Cl2O72 minus, H plus, as well as Cl minus. Okay, so we pick out all the data from the data booklet for both reduction and oxidation. Okay, so it's quite obvious that you will choose the plus 1.33 because it's the most positive value there. For the oxidation, this one there's no need to choose because there's only one choice. So that is 1.36 volt. So if you calculate the E naught cell, you will get a negative value, which means this reaction is non-spontaneous. So what is the limitation for calculating the E naught cell of a galvanic cell? I think I've mentioned this in my lecture 2 when I see you in the LT1 that day. So the E naught cell only allows you to predict from the thermodynamic point of view whether a reaction is spontaneous or not spontaneous. It doesn't give you any info about the speed of the reaction. Okay, it is because there are real examples where you can calculate a redox reaction is spontaneous, but it doesn't seem to occur under room temperature and pressure because the reaction is very slow. So we call this type of reaction to be energetically feasible, but kinetically it is not feasible. Another limitation is that the values that we obtain from the data booklet applies to standard conditions, which means 298 Kelvin and 1 bar, and aqueous concentration of ions is 1 mole per dm cube. So if anything varies or deviates from the standard conditions, the E naught cell will change. Let us now look at another question in checkpoint 7. So what it's trying to say for this question is that Cr2O72 minus can oxidize Cl minus to form Cl2 when you use concentrated HCl. Okay, why is that so? Okay, let me go and highlight the important phrase there. Cl2 gas is readily formed. So that means the Cr2O72 minus is capable of oxidizing Cl minus when you use it in concentrated HCl. Okay. Okay, so let's take a look at the reduction half equation for Cl2 to Cl minus. Okay, when you use concentrated HCl, by applying Le Chatelier's principle, you will shift the position of equilibrium in reaction 1 to the left. This means that the reduction of Cl2 becomes less favorable. So this will give rise to a less positive standard electrode potential value. As a result, the E naught cell of that galvanic cell will become positive and the reaction becomes spontaneous. We will now look at the galvanic cell that is made up of copper as well as aqueous ions of iron. So the standard electrode potential values are given plus 0.34 and 0.77. So Fe3 plus will be able to oxidize Cu2 plus because you can calculate the standard electrode potential of the galvanic cell, which is a positive value, which means that it is a spontaneous reaction. So now in 8i, we are deviating from the standard conditions because when you add water to the copper 2 plus / copper half cell, the aqueous concentration of the Cu2 plus will be decreased because they are now more solvent, or there is now increased volume of the solvent, which is water. So we need to recall what is E cell. E cell, look at the E cell there. The notation is missing the superscript because we are trying to tell you that this is no longer under standard condition. So E cell is actually E2 minus E1, reduction minus oxidation. So when Cu2 plus decreases, POE shifts to the left, okay, which means that the E1 value becomes less positive because now oxidation is favored. And how does this impact the new E cell value? It will be a more positive E cell value. So for checkpoint 8 part 2, adding of OH minus will allow you to see the blue PPT of CuOH2, which means that the Cu2 plus concentration in water is decreased. As a result, POE shift to the left. E1 will become a less positive value, and because this is less positive, your E cell will be more positive compared to the standard cell potential. So for checkpoint 8 part 3, addition of solid copper actually doesn't result any change in the aqueous concentration of Cu2 plus. So there will be no effect on the POE. There will be no effect on either E1 or E2. So the E cell is actually same as the standard electrode cell potential. Okay. Adding water to the Fe3 plus slash Fe2 plus half cell, both the concentration of the two aqueous ions will be decreased by the same extent. So actually there is no shift in equilibrium position. So there is no change into the E1 and E2 value. So the E cell is actually same as the standard electrode cell potential of the galvanic cell. For part 5 of checkpoint 8, when you add solid FeCl2, you are actually increasing the concentration of Fe2 plus, which means the POE will shift left and E2 become less positive because now oxidation is favored. Your E cell will become less positive. Okay, let's look at checkpoint 9. We can easily calculate the voltage for the E naught cell for this example. So you look at your data booklet, you should be able to get plus 0.99 volt, which means this is a spontaneous redox reaction. So now for checkpoint 9 part B, what will happen if I add water to the half cell that contains Cr2O72 minus slash Cr3 plus? So this is not an easy question to answer, but I need you to pay attention. When you add water, right, there are actually more aqueous ions on the left-hand side. So there is a decrease in concentration for all the aqueous ions in the half equation. But the left-hand side will be more affected because there are more ions on the left-hand side. So in the answer that you see here, your position of equilibrium will be shifted left because the drop in the concentration of the aqueous ions is more pronounced on the left-hand side because there are more concentration terms on the left-hand side. As a result, the reduction potential of this half cell will become less favorable because the POE shift left, which means oxidation is now favored. So the E cell will decrease because your Cr2O72 minus slash Cr3 plus is actually the E reduction. Okay, and your E cell equals to E reduction minus E oxidation. And the E reduction decreased, but the E oxidation remains the same. So the effect is your E cell will decrease. Okay. Okay, this is a very nice slide that actually summarizes the battery technology until now. So all of them are actually galvanic cell, but there is a slight difference between fuel cell and the electrochemical cell in this slide. So the fuel cell actually uses a real fuel, and the reaction is actually a combustion reaction, which we will see later. Okay, but in terms of the technology nowadays, right, the lithium ion is the one that we use in our handphone, okay, and electric vehicles, EV. Okay, the current one that we use for our cars, which uses internal combustion engine, is mostly the lead acid accumulator. Okay, so this is found in our ICE cars. Okay, which we known as the internal combustion engine. So we need to know about fuel cells, which is actually stated in the syllabus. So like what I said in the previous slide, there is a real fuel that is being involved in this galvanic cell. So there will be a steady supply of the fuel, which is the reactant. Okay. The fuel will be constantly replaced because it is chemically reacted. Okay, the products that is found or formed as a result of the reaction will be removed. Okay, and examples of fuel will include hydrogen, hydrocarbons, which is like something like petrol, and even alcohols. So for the hydrogen oxygen fuel cell, if you recall what I said earlier in the past two slides, is actually a combustion reaction. So the reactants here are quite familiar. Let me write it down on the slides. The hydrogen is actually the fuel. The O2 is actually what we need for the combustion reaction. Okay. So the species are H2 gas as well as O2 gas, and this is carried out under alkaline conditions. Now we have to look for the relevant electrode potential values from the data booklet. Okay, we should eliminate all those that has H plus in it because we already said that we have carried out under alkaline condition. Okay, so we take away those that are irrelevant, and then we have identified the reduction and the oxidation. So always remember, just now I say that the fuel is your hydrogen gas. So the fuel, you will need to find it on the right hand side, because during a combustion reaction, the fuel is being oxidized. Okay, so with that, we can calculate the electrode cell potential of this galvanic cell, reduction minus oxidation, and you will realize that it is a positive value, which means this is a spontaneous reaction. So a spontaneous reaction will give you a potential difference. This will cause a electric current to run through the external wire in a complete circuit. We can also use the hydrogen oxygen fuel cell under acidic condition, but regardless whether it is the acidic or alkaline condition, the hydrogen is still the fuel, and the species involved is still H2 and O2 gas. The next thing to do is to pick out the relevant half equations under acidic conditions. So let's take a look. Okay, so we cross out those that are irrelevant, because remember, now we have acidic conditions. Okay, so we will be using plus 1.23 and 0.00. Again, please take note, H2 is the fuel and fuel is oxidized. That's why the H2 is on the right hand side. So we can calculate the voltage for this galvanic cell. It will still be 1.23 volt. So the advantage of using a hydrogen oxygen fuel cell is that if you look at the product of this chemical reaction, the combustion of H2 will produce water, okay, which is pollution free. It also gives a high power to mass ratio and is quite a very energy efficient, more than 70%. Okay, the disadvantage for using the hydrogen oxygen fuel cell is because you need expensive metal like platinum as well as nickel, and the catalyst cannot be used forever. They can be poisoned, so you need to replace them, and also you need high temperature as well. Other than the hydrogen fuel, we can also consider hydrocarbons as a fuel in a fuel cell. So remember the fuel, like whether it's ethane or under acidic or alkaline condition, they will need to be on the right hand side because they are oxidized. Okay, so you can actually fill up this table, which is checkpoint. Okay, for checkpoint 10, you will need to write down the half equation that happens at the anode, which is oxidation, and as well as the half equation that happens at the cathode, which is the oxidation. Then after that, you will combine them. So they differ for 1 and 2 is because one is in acidic condition, the other one is under alkaline condition. So let's now start. Okay, so you shall use your AOHE to allow you to come up with the half equation. Then for the reaction at the cathode, please bear in mind for fuel cell 1, you are doing it under acidic condition. Then after that, right, you will need to find the LCM so that the number of electron transferred must be the same. And after you have combined them, you can find the overall cell equation. So you will also do the same thing for fuel cell 2. Bear in mind the difference is that you need to carry it under alkaline condition. Okay. Okay, I will try to show you the mathematics involved for the fuel cell 1 and the fuel cell 2 for the hydrocarbon as a fuel. So let's start. So in acidic condition, we have these two half equation and we need to find the LCM. So times 2 and times 7. Then after that, you will get 28 electrons. Okay, so after that, you can cancel out. And that is the overall equation for the redox reaction for this fuel cell. The same thing can be done for alkaline condition. Okay, and you should get the same answer because after all, the overall cell equation should be a combustion of the fuel. In this case is ethane. We will now take a look at the video for fuel cell.
Hydrogen fuel cells can be used for a wide range of applications, like transportation, material handling, backup power applications, etc. The conventional combustion-based technologies, presently used in vehicles and power plants. It is an opportunity for the fuel cell to provide its benefits. Hydrogen is used to power the fuel cell electric vehicles, FCEVs. It exerts more efficiency over conventional engine vehicles, as it produces no tailpipe emissions, but only emits warm air and water vapor. Let's learn how a hydrogen fuel cell works. Do you know how a battery works? Yes, the fuel cells work like batteries, but they do not run down or need recharging. They can produce electricity constantly. Fuel cells can operate at higher efficiencies than a combustion engines and can convert the chemical energy in the fuel to electrical energy. A fuel cell is composed of two plates separated by an electrolyte membrane. One plate is called anode and the other is cathode. Hydrogen is passed through the anode while oxygen is passed through the cathode. At the anode, the hydrogen molecules are split into electrons and protons by a catalyst. The positive particle of hydrogen can pass through the membrane, but the negative particle cannot pass through it. However, atoms need an equalizing charge, and to achieve this, electron must change the path. That time, the electrons are forced through a circuit and generates electric current and heat. The end product of this reaction is water, H2O. At the cathode, the hydrogen protons, electrons, and oxygen combine to produce water molecules. Due to the lack of moving parts, the cells are highly reliable and its operation is silent. The hydrogen fuel cell is useful in the automobile industry also. Currently, there are several companies around the world working on the development of hydrogen cars. To learn more about the hydrogen fuel cell car, check out our next video. Friends, please share this video globally. Let's grow up. Never stop your learning.
So So after looking at the video, that will be the end of lecture 3, which is the end of electrochemistry part 1, the galvanic cell.